Hello and welcome to special factoring. These are kind of trinomials or difference of squares. I'm going to show you a little bit of a trick here when you run into something like this fraction. Because there's a real easy trick to make this from kind of challenging to quite reasonable. And what we're going to do, we're going to do the following. You know, if I took this and I see this denominator of 2, and if I multiplied everything here by 2, by the same denominator, then I wouldn't have any fractions. So that's what I'm going to do. I'm basically going to go 2 times all of these guys here. Okay, and I'll bring that in a moment, but I just want you to see that I'm going to multiply everything by 2 so that when I expand out this set of brackets here, when I distribute that 2 in, I won't have any fractions. Now, before I go ahead and do that, you might say, hey, you can't just multiply things by 2 because you're changing it. And you're absolutely right. That is quite correct. So we know what I'm going to do. I'm going to compensate this 2 that's out in front by multiplying by its reciprocal. Okay, so if I go 1/2 times 2, then technically this is just the number 1. And I'm actually not changing anything. So that's the trick. So I'm going to leave this 1/2 out in front, and then for the rest of this, I'm going to distribute in that 2. So I'm going to go 2 times 5 is 10x squared. 2 times positive 3 over 2x. Well, the 2's will cancel, and I'm left with the 3x. And finally, 2 times negative 2 at the end, so that's minus 4. Okay, and it's very important I keep that 1/2 out in front, because remember, otherwise I would have changed it. But in this form now, as long as I keep that 1/2 out in front, I've got myself a respectable trinomial here with no fractions. And I can use whatever tricks of the trade are appropriate. So I see here, I think I'm going to have to use a magic numbers approach. So 10 times negative 4, that's negative 40. So I'm going to be looking for 2 factors of negative 40. And these same 2 factors have to add up to make this middle number of positive 3. So I have to think about, well, what numbers might be out there that meet this requirement. And if you think about it for a while, you know, you can go through your candidates here. Like you can try, well, 1 and 40, but there's no way I could add these together to make a 3. So let's move on. 2 and 20. Again, I don't think I can make a 3 out of that. 3 doesn't work, but 4 does, 4 and 10. But they're not 3 apart. So then I come to this one, 5 and 8, and I go, hey, these guys are 3 apart. I think I can do something with that. So if I had 5 and 8, and I want them to add up to positive 3, so that means I want to make the 5 negative. And also up here. And that works because they multiply together to make negative 40. So I got my magic numbers. Now I'm going to put them to work. So I leave my first term, and I rewrite the 3x here using my magic numbers in whatever order. So negative 5x plus 8x minus 4. And I'm going to take the greatest common factor out of the first 2 terms. So that would be, looks like it's going to be a 5x from the looks of things. So that would leave me with 2x minus 1. And then when I take out the greatest common factor from the second 2 terms, I'm hoping to see exactly the same stuff in the bracket. So that's 2x minus 1. So I'm just kind of working backwards here. And that means to get positive 8x, I would have pulled out a positive 4. And positive 4 times negative 1 is negative 4. Yep, that works. So here's my, and I can just squeeze it in here, my final answer. So we have a 2x minus 1 that's multiplying both of those other terms. And those other terms grouped together are 5x plus 4. And there it is, all factored. So if you run into fractions, it's a really snazzy little trick, not a bad way to make it so that you're not working with fractions. All right, I'm going to stop here and come back with some other tricks in a minute or two. All right, so you see in a